All right, good morning, everybody, and happy first International Chart Day, I guess, is today. So I'm going to be talking about using animation to alleviate overdraw and multiclass scatterplot matrices. Again, so I'm Sophie Engle. I'm with the University of San Francisco. I worked on this project with Helen Chen, who was our undergraduate student at the time. She has since graduated, which is why I am talking here today. And with my colleagues Alark Joshi and Beste Yuksel at the University of San Francisco, as well as Ragan at Texas A&M, and Lane Harrison at WPI. So I just want to go through some really quick background. So a multi-class SPLOM is basically a grid of scatter plots. And each scatter plot is going to be encoding a different pair of variables based on its column and row position in the grid. So for example, here, this is a scatter plot in column W and in row V. And so in this particular scatter plot, we're encoding values of W using horizontal position and values of V using vertical position. If I were to move to a different cell in this grid, so for example right here, this is now encoding X values using horizontal position, but it's still encoding V values using vertical position. And this is specifically a multi-class scatterplot matrix. So every single one of these points has a color. It's assigned a color based on some kind of class or category. And that's the class of problems we're studying really, is we're looking at these multi-class scatterplot matrices. And in particular, we're looking at the overdraw problem in these matrices. So the overdraw problem is a very common problem with lots of different techniques, especially for scatterplots and even more so for scatterplot matrices. And it's occurred whenever two or more points end up being rendered in the same location. So we have lots and lots of points overlapping each other, and we have no way of telling what the distribution of data actually looks like. So this is an example SPLOM using just simple alpha blending. And as we discussed in our paper, a lot of the simple techniques that exist don't quite work in this multi-class scatterplot matrix setting. Even some more complicated techniques don't really apply to this specific setting. It's a very difficult and understudied problem. So our approach is fairly simple. We're just going to loop through the data set and continuously redraw points from that data set. So all I'm going to do now is I'm going to push the play button, and we're now animating the scatterplot matrix. So I just want to point you to two things real quick here. So right here is the number of rows that we're drawing every animation frame from the data set. So what that means is every time that we draw a frame in our animation, every single one of these scatter plots is getting 10 new points from the data. And then you can see here is a progress bar, and you can see that we're just looping through the data over and over and over again, redrawing points. And basically the effect that we get is that flickering now indicates overdraw. So I'll go through a couple of cases here. So when we have very few points, basically what we have is something that looks static, that isn't going to be moving very much. So for example, here we have a region where there's very few points and very few colors. We don't really have any kind of movement. Versus a region like over here where we have, again, very few points, but lots of different colors. Still, we're not going to see a lot of movement. Where we're really going to have an effect is when we have lots of points, which is what we refer to as a dense region. So for example, this might not come through super great on the projector, but we have like a bubbling effect as these yellow circles with the white outlines are getting drawn on top of each other. So that means that this is a dense region, but it doesn't have a lot of different classes. It's mostly all of that particular class, compared to something like this, where we have lots of movement, lots of flickering of colors. This indicates that this is both a very dense and very diverse region. There are lots of points and lots of different classes located in this particular region. That's the basics of the idea. It's not a new idea. Other work has used animation in this way, but we're applying it to a new context. The nice thing about this is it does work with interactivity. So if I wanted to, I could highlight just the red points to understand their distribution with the rest of the data set. So I can unhighlight all of those other classes. So now all other classes are being drawn in gray, and the red class, or the B class, is still being drawn in red. And we can tell some interesting things about the relationship of this class with the rest of the data set. So for example, if we focus over here, we can see that this region has most of the points of the red class. They mostly fall in this particular region, but lots of points fall in this particular region as well. Whereas if we focus here, again, lots of the red points fall in this particular region in the scatterplot matrix, but not a lot of other classes fall in that particular region. So this is distinct to that particular class. Now, When we do this for an entire scatterplot matrix, this is a fairly small scatterplot matrix, a lot of the reaction initially is, okay, I can see how this works, but it's really distracting. So does this distracting nature of this animation basically lose any kind of performance boost that you might actually get from using this technique? So of course, we did a user study. So this is the user study. It's running on my laptop now. You can download this user study if you wanted to. It's using the experimenter framework, so you could run it yourself if you wanted to. You don't have to read all of this text. I just want to give you an example of what the tasks looked like in our actual user study. So the first thing we did is we asked some basic demographic questions of our users. So we had 69 participants total. 33% of those were female. We recruited our undergraduate and graduate students from our visualization and visual analytics classes. And since these were all students, the majority of our users were between 18 and 24 years old. You had to be 18 to be able to participate in the study. And then we asked these users how familiar they were with these different techniques, how familiar they were with scatterplots, which they could rate from 1 to 7, and how familiar they were with scatterplot matrices. Since we did recruit users from our class, unsurprisingly, all of our users were at least somewhat comfortable with both of these techniques. Okay, so as far as our tasks go, we did 2 tasks. Our first task is what we call our targeted density task. So again, you'll get to see this text in a little bit bigger a little bit later, but basically we're asking users to drag a black rectangle to a region in a very specific scatterplot for 2 specified variables that has the most circles. So we're directing the users to a targeted area and asking them to select the densest region within that area. We give them a little bit of training of how to interpret this with traditional static scatterplot matrices. And then we give them a little bit of information of how to do this for animated, and then we let them practice. So I want to show you what the practice looked like. So we have, in this particular case, an animated scatterplot matrix. They were able to practice this both in the static case and then the animated case. And it was asking users to drag the black rectangle to a region for variables W and X with the most circles. One thing I want to note here is until you get this black square in the correct scatterplot, you can't click next. So we're forcing people to be able to at least select a region in the correct cell. So if I drag this around, you notice I can't click this next button. I have a warning message until I get it into the right region, which is W and X, and now I can click the next button if I wanted to. And it's going to tell me how many circles I've selected in that particular region and what my best value was. So users could play around with this, practice, and see how they were doing. Now, we then asked users to perform this task 6 times total, 3 times for the static case, 3 times for the animated case. The order that they saw data sets and that they saw static versus animated was fully randomized. And it looks exactly the same as you saw before, except for we no longer have that feedback. They don't know how many circles they've selected. They still have to select something within the correct scatterplot in the SPLOM. So in this particular case, it's W and Y, so I have to drag it somewhere here, and then click next. And so they did that 6 times. I'm not going to do that 6 times in front of you. All right, then we did another task as well. And we called that our diverse density task. So now they could select a region anywhere in our scatterplot matrix, but they had to select a region that had at least 4 different classes or at least 4 different colors. So it had to be a diverse region and a dense region. So same thing, we gave them training and extra information. We gave them the ability to practice. Instead of not letting them click next when they didn't have the right scatterplot, we now don't let them click next until they've selected at least of the 4 colors. So here, if I have only 1 color selected, I still can't select next. If I select more than that, then I can click next. So they could practice this task as well. And then, again, 6 trials, randomized order for data set in the order that they saw static versus animated. Let's say that. And then at the end of this, after they did all of those trials, we asked them how they felt about the animated approach. So we asked them for the static scatterplot matrix, how interpretable was it? We asked the same question for animated scatterplot matrices. And then we asked them whether or not they agreed with the statement that animated scatterplot matrices are distracting. And finally, we asked them which of the 2 techniques did they prefer. So let's look at the results. So just really quickly on how to interpret these particular plots. These are Violin plots showing the distribution of responses from our participants. So here we're looking at the average number of points selected in the animated versus static case for our 2 different tasks. Inside, there are box plots. The box in the box plots show the first and third quartile. The whiskers show 1.5 times the interquartile range. And then that white circle that you're seeing, that's the median. So what did we find? So basically, we found that animated scatterplot matrices did outperform static for both our targeted density task and our diverse density task. And both of these were statistically significant results, which is fantastic. We also found no effect regarding the completion time, how long it took for users to complete both of these tasks. Initially, we felt that animation might increase that time. We don't know that yet. We need more studies. These data sets were fairly small, so they looped pretty quickly. So in general, people really didn't need to spend a lot of time doing these tasks. So if we looked at larger data sets that took longer to loop, we might actually see an effect in that case. So that's an area of future study. And then we asked those questions at the end, so about this interpretability of the two techniques. Now, remember, our users were already somewhat comfortable with scatterplot matrices, but they still felt that the animated technique was much more interpretable than the static scatterplot matrices that they were already familiar with, which is great. And these responses suggest, they align with the performance results, suggesting that users did actually know that they were performing better using animated scatterplots. Now, a lot of that could have to do with all the practice that they were able to do before the tasks, where we were giving them feedback on how many points they were selecting. And then we asked them about their preference. And overwhelmingly, they did prefer the animated scatterplot matrices, which is great news, right? So the performance is better, they prefer them, fantastic. Except for we did have the other question about how distracting it was. And so the way you read this one is anything over 4 means that the user felt that the animated scatterplot matrices were at least somewhat distracting. And there's a good chunk of users there. There's about 30% of our users that found the animation distracting. And very interestingly, around the same number of users also performed worse using animated scatterplot matrices. So this is definitely not something that's for everyone. This motivates the reason why in our tool, you can disable animation or slow down the rate of animation if you prefer, based on your own preferences. So there's a lot of future work that we are having to consider. One of the great reactions to this is everybody has another study to propose to really look at this particular technique. One thing that we really do have to work on is how to handle really large data sets. So we can solve this overdraw problem for fairly small data sets, which is great. It's an area that didn't have a lot of good solutions before. But now we're looking at the diamonds data set with 40,000 rows. And it's great that we can do this in the browser and look at something this big. And we have a nice usage scenario in the paper describing all the things that we learned about this data set using our technique. But one thing I have to point out here is how slow that progress bar is moving. It's crawling. So if you wanted to watch a full loop of this entire data set, you would be sitting here for a while, and we do not have time to do that now. And so there's clearly a problem here. Now, it's maybe something that we can explore using sampling or something along those lines, but it's still an open area of study how we handle these really large data sets. And then we just compared static versus animated just to see whether or not we could get over that hurdle of animation being distracting. And we can, but now we really have to look at these other overdraw techniques, adapt them for a multi-class scatterplot matrix, and do a comparison of all of these techniques to see what's best. Interestingly, animation can be combined with all of these other techniques. It can be combined with sampling, it can be combined with alpha blending, color blending, etc. So it'd also be interesting to study whether or not animation improves those particular techniques. And then there's lots of ways that we can look at how to optimize animation and parameters. So in our user study, everything was fixed. Users couldn't actually disable animation or choose the rate. There are lots of ways we could try to optimize those parameters based on how long it takes to loop through the data set, the performance of the frame rate on their machines, or by some perceptual principles of like how much they're actually going to be able to perceive and adjust the rate of animation based on that. And then lots more. Like I said, we had lots of other ideas of how to continue and explore this particular area. So with that, I just want to point out that we have a great website. We have a live demo on this website. You can play around with some of these different data sets. You can control the animation yourself if you wanted to. We have a nice write-up of how to use our tool. One thing that you may not initially notice is that we do have a lot of these other parameters that you can change using URL query parameters. And in the spirit of open source everything, everything is posted here. So we have lots of videos, etc. But again, our user study repository is posted, so if you wanted to rerun our study as is, you can do that. Our results are posted both in the raw form and our processed form that we use to do our analysis. And our website is posted, so if you wanted to look at our demo code and our website, you have access to all of that. So with that, I'll start taking some questions.
Since I'm here. Catherine Plaisant, University of Maryland. I have a very nice use of animation. I was wondering if you could tell us, and you probably saw some example of, you give people a lot of training, but what do they say if you don't tell them what this is? Like I could imagine people thinking, my God, it's broken.
Yes, and another concern was people that were thinking that we were maybe showing data over time. Since that's how animation is used. I am not sure. I mean, I think that our users thought the technique was so interpretable was great, and that they didn't make that mistake that we're showing data over time, but they were already our visualization students. They don't really represent the general populace. Our user study is experimenter, using the experimenter framework. It is like Amazon Mechanical Turks friendly, so we could try to do this for a different population of people and see how they react to it.
Thank you.
Hi, Danielle Fisher, Microsoft Research. I actually have no questions. I just want to loudly and publicly thank you for putting the reproducibility stuff up. That's really fantastic.
Thank you.
Hi, Ray Molinder, Texas A&M University. I was just wondering if the people who who preferred the static versions performed worse or no different than the people who preferred the non-static version?
We actually still need to dig into those results in more detail to figure out if there is a tight correlation there.
Thank you.
All right, thank you.
Well, I had a question.
Oh, okay.
I was wondering whether you've been thinking about different orders, because it might have an impact on how people perceive and understand the data.
Absolutely, it does have an impact, in fact. And so the data sets that we're showing to you, we actually put outliers first to make sure that if there were outliers in the data set, you wouldn't have to wait for a full loop to see them. We found that like randomizing the order worked best. If you had things ordered by class, it did affect your ability to really perceive those diverse and dense regions. So order definitely does have an impact. We need to explore that further with some additional studies.
Thank you. Sophie?